Now let's move to part B. Okay, express Z1 and Z2 into rectangular form and leave your answer in third form. So class, for the first one here, Z1, which is square root of 21 cos pi over 2 plus I sine pi over 2. Okay, class, let's refresh recall especially to get this one, cos pi over 2 and sine pi over 2. So this is a graph of, let's say, y equal to sine x. Graph of sine x begin from 0 and we call a wave, something like this, where the maximum is 1 and the minimum is negative 1. Okay, so, and here is pi over 2, pi, 3 pi over 2, and 2 pi. So, look at this one here, sine pi over 2, which is equal to 1. So, this value of sine pi over 2 equal to 1. And what about graph of cos x? Cos begin from the maximum of 1 here. Okay, 1 and negative 1. And here is pi over 2, pi, 3, pi over 2. And here maximum again is 2 pi. So this is y equal to cos x. So when x equal to pi over 2, then the y equal to 0. Okay, so this is 0. So now square root of 21, 0 plus 1 times I equal to square root of 21. 0 plus I means that is 21 of I. Okay, sorry. Square root of 21I. So Z2 equal to, okay, for this one here, you may use the calculator of cos 7 pi over 6 and I sine pi 7 pi over 6, where pi equal to 180 degree in degree. So change it in radians, 7 pi over 6. And this is going to give you 2 square root of 6. And it is negative square root of 3 divided by 2 minus 1 over 2 I. Okay, so when this multiplied with every single term that we have, so 2 divided by 2 and also divided by 2 here, so it's going to give you square root of 6 multiplied with negative square root of 3 and minus square root of 6 with an I. Okay, so simplify this, it's going to give you negative 3 square root of 2 minus square root of 6i. Okay, so now find Z2 divided by Z1. Z2 divided by Z1 equal to, okay, Z2 here now is negative 3 square root of 2 minus square root of 6i divided by square root of 21i. Okay, square root of 21i. Okay, so we are going to eliminate this square root of sign of square root here from the denominator by multiplying with square root of 21i divided by square root of 21i. Okay, so then the first one here multiplied with this, okay, negative 3 square root of 2 square root of 21i, and then minus negative 6i times this minus square root of 6 square root of 21i multiplied with I, which will give you I squared, divided by this one here, 21i squared. Okay, so class, let me make this recall, make a clearance on this first. Okay, so negative 3 square root of 2 times 21 equal to negative 3 square root of 2 times square root of 21 square root of 42i and minus square root of 6 times 21. 21 is 7 times 3. So which I think that according to this one here, let me try again if we can simplify this. Okay, so negative 3 square root of 2 square root of 3 and square root of 7i, and this one here negative 6 negative square root of 6 times negative of this one here minus square root of 1 to 6i, and everything divided by square root of 21 times square root of 21 is 21i square times I square, I times I equal to I square, and also I square here. So this is going to give you negative 1 and this is going to give you negative 1. So then negative multiplied with negative, positive. So minus okay, so for this one, which I think that I'm going to give you my own answer for this one here now, which is 2 times 21 square root of 42 minus square root of 1 to 6. Negative with negative, positive here. And we have I and divide by 21. Okay, so class, this is in the form of square root of 1 to 6 divided by 21 minus 3 square root of 42 I divided by 21. Okay, so modulus of Z2 divided by Z1, which is square root of square root of 1 to 6 divided by 21 square, plus with negative 3 square root of 42 divided by 21 square. Okay, you may press the calculator and get your answer for this one here. Okay, so let's move to the next question then. So for question number 2a, e power of 2x minus e power of negative 2x divided by e power of 2x plus 5 e power of negative 2x equal to 1 over 4. So cross multiply 4 multiplied with this one here, and the denominator of this multiplied with 1 is going to give you e power of 2x minus 4e power of negative 2x equal to e power of 2x plus 5e power of negative 2x. So bring all this to the left side. So 4e power of 2x minus, or bring this to here, bring to the left side, become negative. So 4e 2x minus e power of 2x, 3e power of 2x, and 5 positive here become negative. So minus 9e power of negative 2x equal to 0. And then 3e power of, okay, from here, let's multiply with e power of 2x. Okay, every single term that we have here, multiply with this one here, going to give you 3e power of 4x minus 9 plus e power of negative 2x multiplied with e power of 2x. Okay, it's going to give you e power negative 2x plus, okay, multiplication between these two, okay, and equal base, it's going to give you positive here from the rules of a times n to the power of a times n equal to a to the power of m plus n. So it can give you 2x here. So negative 2x plus 2x equal to e to the power of 0 or equal to 1. So then here between this and this, it's going to give you 1. And of course, 0 multiplied with any numbers, it's going to give you 0 here. So 3e power of 4x equal to 9. E power of 4x equal to 9 divided by 3 equal to 3. And we come out with ln left and right. Okay, so ln is a log to the base of e. With the e here, bring it 4 to the front here then. 4x natural log of e equal to natural log of 3, where ln e equal to 1. Okay, 4x equal to natural log of 3, then x equal to natural log of 3 divided by 4. Okay, so the next question is here. Okay, 4 divided by x plus 1 less than or equal to x minus 2. So 4x plus 1 class. This is inequalities, not equation. So we cannot simply make a recall the process of cross multiplication between this x plus 1 with x minus 2. So what are we going to do here now is bring all this to the left side, become negative x minus 2 less than or equal to 0. Okay, just assume that this is divided by 1, x minus 2 over 1. So because this is a fraction here, okay, 4 divided by x plus 1, so we are going to equalize the denominator then by multiplying this with x plus 1, also x plus 1. Okay, so 4 minus x times x squared with negative x squared. X times 1 is x, negative 2x, so negative 2, negative 2x plus 1x equal to negative 1. Negative 1 with negative positive x. And then negative 2 times 1 equal to negative 2 times negative positive divided by x plus 1 less than or equal to 0. Then we have negative x squared plus x. 2 plus 4 equal to 6 divided by x plus 1 less than or equal to 0. Okay, so now let's see if we can factorize the numerator here. Okay, divided by x plus 1 less than or equal to 0. We have negative x and x, so 6. 6 is either the combination of 1 multiplied with 6 or 2 times 3. And the difference here is positive 1. But don't forget that we have the coefficient of x squared, which is negative 1 here. So to me, it's not logic for the combination of 1 with 6 here because difference here is 1. So this is not the pair we're looking for that. So 2 with 3, yeah, might be. Okay, so now negative x plus 2 and plus 3. So let's see, negative x times x, negative x squared, negative x times 2, negative 2x. 3 times x equal to 3x. So 3x minus 2x equal to an x. And 3 times 2 equal to 6. Okay, now, class, in this case, no matter whether the sign of this is greater than or equal, less than or equal, greater than or less than, so we just assuming first that all these linear function here are positive. Negative x plus 3 greater than or equal to 0. X plus 2 greater than or equal to 0. X plus 1, the denominator, cannot be equal to 0. So we just put it as a greater than only. So negative x greater than equal to negative 3 and x less than or equal to 3 multiplied with negative. So the direction changed last year. X greater than or equal to negative 2 and x greater than negative 1. And now we're going to analyze this. Okay, we have negative 2, negative 1, and 3. So the first one here, less than or equal to negative 3. Then the rest of it is greater than and greater than. So we divide it into 3 parts here. So this we consider as negative. And also here, negative, negative. Okay, I'm going to use the different colors here. Okay, without the line of this on this area, we assume it's negative, negative, negative. So this one is positive, 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 negative. Okay, so now let's analyze negative value multiplied with negative value, positive. Positive times positive, positive. Positive times positive, positive times negative, negative. Positive and negative. So class, these inequalities here, on this part here, which is less than 0, the numbers that less than 0 are all negative. Good. Here and here. So the final solution set, which is from negative 2 to negative 1. Okay. Union from 3 to positive infinity. Okay. Okay. Negative 1 here is not this is not we call a black dot, it's a circle which is greater than negative 1 only. So here. Okay, there you go. Okay, now next question here. State the domain and range of this function in the diagram below. Okay, so you can see here now it begins we call from value of x equal to 0 until x equal to 2 pi. Okay, so automatically the domain of this function is from 0 until 2 pi. And the range of this function, look at this one here, where is equal the value of y is from 2, okay, to negative 2. Negative 2 until 2. Okay, so this is it. State the domain and range of this function according to the diagram here. So this is the answer then. Okay, now given that 2x, okay, find h not hx. So now h and hx. Firstly, hx equal to 2x divided by x minus 2. And composite function means that we're going to substitute the whole function into an x of the other function. So it means that here, substitute this into an x of the function h. Actually, recall that in this question here, both are h. So just we can refer to this 2x divided by x minus 2. 2x, 2x, and x minus 2. So here we're going to substitute with 2x divided by x minus 2 and also 2x divided by x minus 2. Okay, so multiply with this one here, going to give you 4x divided by x minus 2. This one, this part. And now for this one here, class, just imagine that this is 2 over 1. So to equalize the denominator of this, we're going to multiply with x minus 2 here and also x minus 2 on the top here. So then divide by, okay, the denominator of this, 2x and negative 2 times x minus 2x, negative 2 times negative 2, 4. Divide by x minus 2. 2x minus 2x equal to 0. So what we have here right now is 4 divided by x minus 2. Bring above for this one here. So switch the position upside down. It's going to give you x minus 2 divided by 4. Okay. So then let's take a look at this. X minus 2 divided by x minus 2. 4x divided by 4. 4 divided by 4. So what's left here now? x. That's it. So, hence state H inverse. Class, if given to you a function of fx, okay, and gx, so when we make a composite function process of f, gx, for example, and finally, we get a result of equal to an x. So we come up with a conclusion that gx is actually an inverse of the function of fx, meaning that gx equal to f inverse. Okay, so what are we going to say about this one here now? For this, how am I going to write down this one here? Okay, so then H inverse equal to 2x divided by x minus 2. So class, this function is quite unique because it can be H, the function of H, and it can be inverse of its own function. Okay, it can be inverse of its own function. Okay, now a function is defined by this one here, determine whether f is a one-to-one function. So let's say fx1 equal to fx2. So which means that area 2x1, modulus of 2x1 minus 1 plus 3 equal to modulus of 2x2 minus 1 plus 3. So let's say bring up here 3 minus 3 here. So 3 minus 3 equal to 0. And class, for this, modulus of fx equal to, we have fx, which is when fx is greater than or equal to 0, and negative fx when fx is less than 0. Meaning for this, let's say we have 2x1 minus 1 equal to negative of 2x2 minus 1, or 2x1 minus 1 equal to 2x2 minus 1. Okay, so if I recall, simplify this first, negative 1, bring it here, become positive 1, equal to 0, and 2x1 equal to 2x2, and divide by 2 left and right, it will give you x1 equal to x2. Let's take a look at this one here now. 2x1 minus 1 equal to negative 2x2 plus 1. Okay, bring up this negative to the positive here. So it now become negative 2x2 plus 2. Okay, and then divide by 2 left and right, or multiply with 1 over 2 here and multiply with 1 over 2. So then x1 equal to, now become negative x2 plus 1. Okay, so class, x1 equal to x2 and x1 equal to negative x2 plus 1. So with one value of x1, there are two values where is equal to x2 and negative x2 plus 1. So the conclusion here, fx is not a one-to-one function. There you go. Okay, so the next, question B. Given that fx equal to 3 minus e power of negative 2x, find the domain and range of f. Okay, so now class, let's take a look, focusing on this one here, y equal to e power of negative 2x. So when x equal to 0, e power of, x equal to 0, 0 times negative 2 equal to 0. So then e power of 0 equal to 1. When x approaching to positive infinity, when x is getting bigger and bigger, multiply with negative 2, then become negative. So e power of negative big numbers, e power of negative 10, or might be 100, or might be 1000, and this one, e power of negative 2x approaching to 0, okay? Because this is 1 over e power of 1000, okay? When x approaching to negative infinity, when x is getting smaller and smaller, e power of negative 2 and negative 100. So look at this one here, negative times negative, positive. And 2 times 100 is a big number. So when x approaching to negative infinity, e power of negative 2x approaching to positive infinity. Okay, so just imagine that uh, when x equal to 0, y equal to 1. Okay, it is 1 here when x approaching to positive, then this one approaching to 0 and x approaching to negative infinity, then it's getting bigger. So it's something like this. Sorry. Okay. There you go. Okay. But then, class, when we have this 3 minus e power of negative 2x, so for example, when x equal to 0, e power of 0 equal to 1. So when x equal to 0, f 0, then 3 minus e power of negative 2 times 0. And this is 1. So 3 minus 1 equal to 2. Okay, so earlier for this case, the horizontal asymptote is x-axis or y equal to 0. But then when we look at the the real function here, then when x equal to 0, e power of 0 equal to 1, then 3 minus 1 equal to 2. Now this one become the new horizontal asymptote. Okay, and this is the new graph of this function. Okay, I'm sorry. Sorry. Okay, stop here. Okay, means that the graph shift 1 unit above. Okay, class, so I'm going to sketch the proper graph for this. Okay. Okay, the intersection at x equal to 2 here, and y equal to x equal to y equal to 1 as a new what we call horizontal asymptote. So this is the graph. 2 and 1. Okay, to sketch the graph, okay, before that, I'm going to clear this. Okay, because the question wants us to sketch the graph of f and inverse on the same coordinate axis. So class, let's say before we sketch the inverse, we need to make some extra work here where we're going to sketch the line of y equal to an x, where this line of y equal to an x is just like a reflective mirror. Okay, reflective mirror between the function of f and its inverse. So now, let's say when they have y equal to 1 here, so we opposite of this, we're going to come up with a line of x equal to 1. Okay, and intersect at y equal to 2, bring it here, it become intersect at x equal to 2. So now, just imagine that this graph reflects between the line of y equal to an x, so then become, there you go. This is the function of f inverse. So now class, according to, might be from the calculation or from this picture of graph, find the domain and range of f. What is the domain of f and the range of f? So the domain of this function, you can see clearly here, is all real numbers from negative to positive infinity. And the range of f, which we refer to the value of y, where the value of we call this function approaching to the line of y equal to 1. So approaching to line of y equal to 1, and then the rest is of what we call positive infinity. So then it come up with 1 to positive infinity. And class, if the question wants you to find the state, the domain and range of f inverse, please remember that the domain of f is also the range of f inverse, and the range of f equal to the domain of f inverse. So we can make a conclusion here, or make it short, that the domain of f is also the range of f inverse, and the range of f is a domain of f inverse. There you go. Okay, now the first one then here,